Tomtech's Harvester 96 has served the market very reliably for over 20 years. During the high-throughput screening era of the 90s, the Harvester 96 was the essential supporting instrument for scintillation counting. While scintillation counting has diminished in use, it is a very viable method for many applications. Over the years, Tomtech has made several Harvester 96 models. The Mach 2 was designed to support the 6x16 spacing of the original Wallach beta plate. The Harvester 96 Mach 3 design was created to support the 8x12 spacing of microtiter to support both the Wallach Micro Beta and the Packard Top Count. PerkinElmer has since acquired both Wallach and Packard. Today's Harvester 96 Mach 3 is available in two forms, to support glass fiber filter mats or the 96 Unifilter plate. Both versions are available as a fully programmable version of a lower-cost model with less programming capability. The basic purpose of the Harvester 96 is very straightforward. Wash buffer is added to a cell plate and then aspirated through a glass fiber filtration media. The purpose of the filter media is to trap or contain the particulate matter as it flows through, which in this case are the cells. However, the filter media stops particulate matter, both live cells and dead cells. Scintillation counting of the filter mat is used to measure the live cells. For a typical cell proliferation assay, live cells are grown in a growth medium containing tritium, a low beta emitter. As the cells grow and multiply, they take up the radioactive label. If there is no growth, no tritium ends up in the cell. Assume a growth inhibitor, which is the agent to be tested, is added to the growth medium, as well as the tritium. The rate of growth inhibition can be determined by using scintillation counting to count the tritium in the filter mat, which is a direct measure of cell growth. This is a very useful research tool. While there are other cell harvesters on the market, none of them can match the record of performance that the Harvester 96 has achieved. This is due to the basic instrument design. The wash fluids used in cell harvesting are salt buffers. If excellent care is not taken in rinsing the system after use, these salt buffers dry and cake the small flow passages that are involved. If the wash buffer going through each 96 wells aspirate path is not the same, then there is a loss of equivalence between wells, unknowns, and standards. The Harvester 96 uses removable wash tips. A simple uniformity of volume test is easily made. If the results are poor, the offending tips may be easily removed and washed ultrasonically or simply replaced. Each tip has 4 small wash orifices that uniformly add wash buffer to each well. These wash orifices are high up on the wall of the well. Thus, the wash buffer runs down the well side walls to the aspirate needle at the bottom of the well, providing efficient removal of the cells through the filtration media. Another important feature of the Harvester 96 tip design is overflow protection. Excessive cells in a particular well can occlude the portion of the filter mat, thereby slowing the flow rate in that well. Since that well is not being aspirated fast enough, it will fill with wash and overflow to the adjacent well or wells. Each of the Harvester 96 tips has 4 overflow channels that connect to the vacuum source. If a well starts to overflow, the vacuum in the overflow channels will capture the excess, preventing the overflow to the adjacent wells. The flow passage from each well through the filter mat must be sealed to prevent crosstalk between wells. The Harvester 96 uses an O-ring on both sides of the filter mat to completely seal a specific filter mat area to its supply well. More importantly, is the means of clamping the filter area. The harvester head must swing open to allow placement of the filter mat or filter plate in position for harvesting. The Harvester 96 design uses a patented double action for clamping. The head first pivots down into position for the clamping action. The clamping action then takes over to pull the O-ring seals straight down for the final clamping function. This effectively seals off each 96 well segment of the filter mat. The programmability of the automated version is another unique feature of the Harvester 96. The operator may create 16 individual harvesting protocols. Each protocol consists of 5 separate programmable sequences. The wash time may be set to fill the well with wash, or soak time may be created. The well may then be aspirated. A sequence of wash aspirate may be created that is unique to a specific protocol. That protocol may be saved and called by name on command. When using the 96 well unifilter plates, there is a potential flow rate situation. The unifilter plate has a small filter area. In addition, there is a molded mesh that restricts the flow rate even further. A pulse wash program may be created for this situation. A short wash followed by a quick aspirate prevents overflowing the wells. This quick sequence can then be created in times as determined by the protocol requirements. This type of program control can be mimicked with the manual programming version of the harvester. It takes more programming time to create it, and it is not recalled that easily, thus the difference in price. As an accessory for the Harvester 96, Tomtech provides our auto trap. A trap is required to separate the water from the airflow going to the vacuum pump. The auto trap is a Teflon-lined stainless steel container capable of holding 10 liters. Note the use of a Teflon lining in addition to the stainless steel. The salt buffers used in cell harvesting can be very destructive to metal. The auto trap is float level controlled. When full, it allows the current program to end, but will inhibit starting the next. The auto trap is emptied by flipping a switch. Personnel will never have to come in contact with the hot waste. When switched to empty, the vacuum valve to the auto trap is closed. A drain valve opens and concurrently low air pressure is applied to the auto trap to empty the contents. A flip of the switch returns to vacuum control. There are several simple tests that you may run at will to check the operation of your Harvester 96. 1. Are the wash tips delivering wash properly? Multiple dispenses from the wash tips are made into a rack of 96 tubes. The instruction manual describes the procedure. After the required cycles, the liquid level in each row of 12 is observed for the allowable variation. 2. After harvesting to a filter mat, there should be 96 wetted circles. If there is evidence of crosstalk between the wetted circles, check the O-rings and the clamp pressure. 3. Did your protocol use too fast a wash rate, causing overflow in the 96 well source plate? Examine the source plate after harvesting. Most 96 well plates have cavities between the wells. If there is a wash liquid in these cavities, it means an overflow condition existed. 4. I am not getting consistent results with my protocol. A. Was there crosstalk between circles on the filter mat? If not, it means that whatever fluid was aspirated went through the designated area of the filter mat. B. Was there any fluid captured between the wells or the source plate? If not, it means all the wash applied to the well went through the filter mat. A and B are the only performance criteria the harvester has any effect on. If all wells receive uniform wash amounts, volume checked OK, and the wells did not overflow, and the filter mat did not show crosstalk, the problem is not mechanical. The problem is in the protocol. There may not have been enough wash or too much wash. Some harvesting protocols use TCA to create a precipitant. The harvester is made of aluminum. Aluminum and TCA are not compatible. TCA will go through aluminum very quickly. If you are planning to use TCA, you should purchase our stainless steel harvester model. It is designed for the use of TCA. We hope that the protocols we have covered in this DVD can assist you in your harvesting protocols. If we can be of further assistance, please contact us. We thank you for your time and interest in our products.